Imagine that you're a kid. Because of your class's good performance in the last exams, your teacher has decided to give out candies to the class. And because the exam was a math exam, he's going to be giving out candies according to a special pattern. He gets everyone to sit in a circle and gives out candy starting from the first child. Next, he skips one child and gives the candy to the third child. Then he skips two children and gives the candy to the sixth child. He continues this way, each time skipping one more child than he did before. In order not to show bias, your teacher wants every child to get at least one candy. The question is, can he ensure that all children get a candy? We want to find a general formula for the number of children and prove that it works. So here are some variables we'll use to represent different things in the problem n. Sorry, I kind of got absorbed. Let's try another form of explanation. This is the data for the case when the skip sequence was 1, 2, 3, and so on in the form of a table. When the number in a cell is 0, it means that the last child will get a candy. Note that there are some patterns that can be observed from the table. Based on the table, we can form what we call a congruence equation for the number of the child that will receive the candy. It might sound complicated, but basically using this equation, we can generate the number of the child that receives the nth candy. So this is the part of the proof that was previewed just now. The more important part of this is the last part here. Putting it simply, the conclusion of the proof was that when there are 2 to the power of k children, each child will receive exactly 2 candies in one cycle. But as you figured it out, the teacher starts thinking that maybe the sequence has become too predictable, and so he wants to change the pattern. What if we give out candies according to a geometric progression skip sequence? That could be interesting. And well, it does look like every child will get a candy. And that sounds like the way our teacher should be giving out candies from now on. Of course, there are other applications such as cryptography and the like, but I'm not exactly experienced in that area, so I'll move on. Before I end off, there are many other sequences that can be explored for this question. I myself have been trying the Fibonacci sequence, and so far, there's been no pattern at all, though it does look like every child will get a candy. Maybe you can be the one to figure this out.